I'm Sanket, and I'm waiting for the slides to come up. But yeah, as Brent mentioned, I've come all the way from Bangalore, and this is the first in-person conference after the pandemic. So very, very excited to be with you all. So yeah, I'm Sanket, and you might have seen that picture on the internet. So you can map the face. That's what we do here at conferences, right? You might know me from this library called Native Base, which is a UI component library for React Native, and now it also works on React. I also co-founded this company called Geeky Ants, where Native Base is one of the projects. And yeah, you can follow me on Twitter. Goes by Sanket Sahu. Great. So my topic for the day is the state of one code base for all the platforms. Like, write the code once and then deploy it on all the platforms. When I say all the platforms, it's not only Android or iOS. It also includes the web. And as you might have already guessed, this talk is about Flutter. OK, just kidding. This is about Java. Anyway, this is about a lot of different things. And that makes this entire ecosystem of React and React Native to make it work on all the platforms out there. Let's talk about the approaches that we can take to have this one code base for all the platforms. The first approach would be you take native platforms. It can be Android, iOS, or web. Take the Canvas API straight away, paint to pixels, and take back the events from the canvas to your single source framework, one code framework. And then maintain everything in the source framework or source language, like maintain the widgets, maintain where it is placed. And when an event happens, you wire it up back to your widgets tree and see which widget was actually, or which component was actually tapped on. So this is one approach. There are obvious pros and cons for this. The pros is like the glue is really thin. When you want to target more platforms, you straight away go and write the mapping, which is pretty thin in terms of you just need to paint the pixels. You don't need to deal with a lot of other hard problems. Second, it guarantees consistency. And there are downsides, obviously, that you have to reinvent the UI, platform-level UI patterns. And also, it makes it hard for you to do accessibility. Say, if you are painting the pixels, you have to identify things like keyboard focus and mouse pointer and a bunch of those things. So accessibility is difficult with this approach. You might have guessed this approach is used by a bunch of different frameworks and languages. For example, Flutter uses Dart plus Skia engine. Ionic uses JavaScript and WebView. Java uses its own UI engine. Unity has its engine written in C#. And then we have Qt, for example. Then we have the second approach, in which we use the native widgets. We use the native OEM widgets, that's what we call it. And we wire it up with a thin mapping, and then rely on platform for things like accessibility and functionality. So it has some good advantages, like no need to re-implement the platform components and UI patterns, for example. Native accessibility is very easy to implement. And adding new component is like you can straight away use the existing platform components and wire it up with minimal API. And you don't really need to recreate those components. On the downside, we have like mapping every component of every platform. It can get really hard. And consistency is also really difficult, because there might be some APIs that's available here in one platform, which is not available in some other platform. One example of this would be like shadows on Android is very different than shadows in iOS, because in React Native, we use the native shadows, which is difficult to achieve. So yeah, this is used in frameworks like Xamarin and React Native. But there's essentially more than painting the pixels. We have the UI patterns that is different on platforms. We have navigation, which is very different between mobile and web. We have accessibility. We have animations and gestures. We have native modules, and we have like different build systems. If we talk about user interface patterns, it differs from Android, iOS, and web. For example, if you look at this example, this is very Android sort of material design, which is not really seen in iOS apps. The hamburger icon you can see at the top left corner, which is not seen on iOS. Similarly, we have status bar. Status bar is at the top of like all the apps on Android and iOS, is not really present on the web. And what we are trying to do is we are trying to do one code for all the platforms. So we have to consider all these little details of all the platforms. Navigation is the hardest problem, and we have some talks lined up after this. But yeah, mobile navigation is more like stacks. So it stacks on top of it. It preserves the entire state when you go back, and you don't need to refresh the entire navigation. You can just get back the same state. But on the web, which is designed with request and response at its core, it's like a new state all the time. You can do a hard refresh anytime, and the users would essentially come back to the same state. And it's our responsibility as app developers or web developers to get that back. And then comes accessibility, which is very, very different on all these apps, on these platforms. Accessibility makes our apps inclusive, but the APIs differ a lot. It has a lot of checklists, right from, say, contrast ratio to text. Let's look at the checklist. We have screen readers, like all the apps must be compatible with screen readers. We have focus control. We have keyboard interaction, mouse and touch events, color contrast, and whatnot. And the APIs, for example, we have TalkBack for Android. We have VoiceOver for iOS. And then we have different set of APIs for the browsers. And then we have animations and gestures, which is different on all the platforms. For example, if you swipe right from the left edge of the screen on iOS, the chances are high you would go back on the last screen. But that's not the case with Android. It doesn't happen in web at all. The ripple animation on button is a material-specific thing. Similarly, pull down to refresh is a very mobile-specific animation and gesture. And then we have native modules, which is different, like right from cameras to NFCs to Bluetooth, Wi-Fi, and all these APIs. The web is catching up lately, but it is a very mobile sort of thing that we have. But we want to write one code for all the platforms, including the web, right? Build system is equally different. Like, we want to do one code and then build it for all the platforms, and then generate APK, IPA file, and the JS bundle for web. Let's look at like how we can use React and its ecosystem to achieve that. Starting from user interface, React is a nice toolkit that helps you build interfaces. We have React DOM on one side for web. Then we have React Native for Android and iOS. We can essentially use React Native Web right before using React Native DOM, which provides a common API for us to write for all the three platforms. So essentially, we can maintain one code and then deploy it for all the platforms, including web. So React Native Web makes our job very easy. Then there was an experimental project by Vincent Reamer. I guess it was announced at React Europe, but it's still experimental. This project brought us the same multi-threading architecture of React Native on web, which was really nice. Let's look at the UI libraries that makes this possible. We have UI libraries that's supported on all the three platforms. We have Universal UI library by Showtime, and Axel is going to give a very nice talk on this at 3:30, so I won't detail it down further. We have Dripsy. This is a very thin styling engine on top of React Native. This is by Fernando Rojo. And I really like this caption, style once, run anywhere. It has a very elegant API. So it's essentially an extension of React Native components. And you get this SX prop, wherein you can pass all those things like font size, responsive font sizes like 14, 16, 20. Then we have colors, and we have tokens there. Like you can use primary color And these three are like responsive colors for all the three screen sizes. So yeah, I really like this nice little library by Fernando. And then we have Tumug UI, which is a very nice pre-compiler, optimizing pre-compiler. It says universal design systems for React Native and web, but faster. It comes with a nice optimizing compiler that gets rid of React Native web completely on the web, and it essentially provides the same API. So it is fully compatible with the APIs of React Native, but during the build time, it strips off all the React Native web source code. So on the left, you can see the code that is app.tsx. We have Y stack, we have text. But that essentially transpiles to a build time CSS classes, and then we have low-level elements like div and span on web. This essentially maps to something like a stack or maybe a view and a text on React Native, but on the web, it completely strips off React Native web. I'm very excited to see this project. And then we have Expo HTML elements. This was one of the experimental projects by Expo, which gives you the semantic tags on React Native. So essentially, you can use the same learning of HTML and CSS here to build like universal apps. And the last one is native base that we created at Geeky Ants. This is a universal component library for React Native and web. And it's a utility-first component library. What that means is you can use Tailwind-like API in the components. Like, for example, we have a box component here. And we have px as 3. That is like using the 3 token, the $3 token of the theme to have the padding, something very similar to what we do in Tailwind. And then we have, say, bg is equal to primary.400. That's another token. And then we have responsive props, like MB is 4 and 5 for 2 different breakpoints. And we have text, font weight, color, font size, all those standard things that you would need to build a very flexible component library. Then we have navigation. Navigation is, again, very different on web and mobile. We have React Router, the famous React Router that works inside Create React app, and you can also do a bit of SSR. And Next.js has a file-based routing, which is well adopted in the front-end web developers community. For mobile, we have React Navigation, which is really good for, which is the go-to thing for React Native apps. Then we are seeing some adoption of like URL-based routing inside React Native. I was speaking to Alec just yesterday, and they're working on React Native URL router, which essentially takes in the APIs of React Router and brings it to React Native. I hope the motivation is like in the future they can share the code between web and mobile both. But what I'm really excited about is a project like Salito. This is by Fernando again. This brings in the inspiration from Next.js to React Native and essentially gives us 2 entry points. So this library is 2 things. One, it's a tiny wrapper around React Navigation and Next.js that lets you share navigation code across platform. And it's also a set of patterns to how to share code among like different platforms. So essentially, when you are building, say, pages, you would end up in navigation code inside your pages. And you want to share that navigation code between web and mobile. So if you completely replace your link tag that comes from Next.js with a Salito link tag, it's a drop-in replacement of that. And you can get the same thing on web projects. And it would essentially map to the APIs of React Navigation in your React Native project. So you can completely share the complete project or the pages or the screens in your app. This is really nice. Then comes accessibility, which is, again, very different. If you go to the React's documentation, there's a lot of guidelines and practices that you need to do, like standards like WCAG and WAI, ARIA. Then we have semantic HTML. Then we have accessible forms, how to build them, how to have focus control of keyboard, and how to use that outline thing, how to use mouse pointers and events. And it goes on and on. This gets really complicated. If you are building an app, web or mobile, you get to a point that if you want to make it accessible, it's like a lot of work. And that's why our friends at Adobe, they built this project called React Aria. This is a set of hooks that you can drop into your components, and you can make those components accessible. A quick example of this would be use button hook that comes from React Aria. You can use the hook, and you can spread the props that it gives you back, the button props from the hook, and then spread it on a button component. And then you can use this button component that is accessible. By accessible, it means that it works consistently across mouse, touch events, keyboard, screen readers, and everything. So it does all those things, whatever was mentioned in the React guidelines for accessibility. And we at Geeky Ants worked with Adobe to build the next version of React Aria, or an extension of React Aria that works with React Native. This is React Native Aria. So it's also a set of hooks that gives you the accessibility props on native and mobile and web. So here's a quick example of how you can use or how you can build a checkbox component which is fully accessible. So you import use checkbox from React Native Aria, and then check for platform. If the platform is web, you can spread it straight away on input props. And then if it is mobile, you can spread it on the pressable component. And now we have a fully accessible checkbox, which is like if you press tab on web, it would get the focus right. If you click outside, it takes the focus away. If you use a screen reader, it would read out the I agree text that's next to the checkbox. So it does a lot of things. So by using React Native Aria, which uses React Aria on web and builds its own accessible props on native side, you can make fully accessible components like this. So we have a bunch of other hooks that's available. Then we have animations and gestures. We had a very nice talk. The last talk was on animations. But yeah, quickly checking what's the animation API like in React Native. So we have two animation APIs, Animated, and then we have layout animation. So if we have to build something as simple as a fade-in animation like this, we would essentially have to go through and import Animated from React Native, and then we create an animated value with a reference, give it some timing and the duration of it and use effect, and then go ahead and return the animated.view component. And then later replace it with a standard view component with a fade-in view. So it's a lot of work to get something as simple as like a fade-in animation in React Native. This essentially works with React Native Web as well. So you get the cross-platform behavior. But the API can be hard. So to solve this, I really like the API of Framer Motion, which simplifies this entire thing. Like you can use motion.div and then say animate initial and transition, which is very declarative and nice. But this is for React. Framer Motion works for React. We have React Native Reanimated, V2 and V3 both, which is really great, which extends the API of React Native Animated. And now it also works with Fabric. That means you can get full support of native animations. So what Fernando did is he took the inspiration from Framer Motion, used the APIs of Framer Motion, and wrapped it inside Reanimated V2 to give us an API like this, which is motif view, and then from animate and exit. This works on all the platforms flawlessly. So there's some great work. And then we have native modules. The harder problem is being solved by Expo. We have a bunch of native modules. For example, maps, camera, notification. We have a lot of them. And now Expo is taking that extra effort to make all those APIs compatible with web. If you look at the camera API, it's supported on web. The two red crosses are for emulators, so obviously. It works everywhere. So we have the same API of Expo camera that you can import and then set some state and use it in your app with a very standard practice. And this just works everywhere on all the platforms, which is really cool. Last one, build systems. I think Charlie spoke about ES service by Expo, which is amazing. So Expo provides you ES service to build APK and IPA file for different platforms, right from like building to distribution, and it covers everything, which is really cool. But what about web? I think at some point, Expo would support like 100% web-compatible builds and everything on the web. But until then, we have Salito, which gives us 2 entry points. One is for the EAS builds. Another would straight away give you a Next.js project that takes you to the Vercel build pipeline. So it works really well. Yeah, so I want to conclude with a few things. This article by the React Native core team, which says React Native's many platform vision. They have made some really good points. A few of them are respecting the platform. The first one is embracing platform constraints, which says that the React Native core team, they borrow learnings from one platforms and then apply it to other, which is really great. If you look at how they got performance improvement on Android, they flattened the entire tree into one single flat tree. And with a switch of a button, they implemented the same thing on iOS. So we could learn from Android and then reapply it to iOS. And yeah, I like how they use cross-pollination of institutional knowledge between the platforms, which is great. And that ultimately drives competition. I mean, competition drives innovation, which is, I think, great about React Native, that because we are learning from all the platforms and building a thing on top of it, which is unified, which is really great. And it's expanding to new platforms. In the end, I want to say the future of React Native looks very promising, and the future of one code base for all the platform is very, very exciting. That's all from my side. I'm Sanket, and you can connect with me on Twitter. Thanks.